Hello everyone, today our group gonna present about time series analytic. My name is Punnapa PRAMOTEKUL 6610545863.
My name is Supidcha NILSARIKA 6610545545. Let's get started. Our primary data source correct indoor temperature and humidity by use the KY/015 sensor connected to kit by board, and our secondary data source correct by use the Open Weather API to correct outdoor temperature and humidity. Our compact data contain asynchronous correction, time series nature, and imbalance data. Asynchronous correction: indoor and outdoor data correct at different intervals. Challenge: Wi-Fi dropouts cause indoor data grab while outdoor data continues. Solution: merge dataset, use +/- 5-minute windows to arise observations. Time series nature corrected only from 9 to 18 on non-consecutive days. Key issues: large overnight gaps between sessions, variable correction days create inconsistent weekly patterns, impact sharing in monitoring daily and weekly seasonality, requires careful handling of missing periods. Imbalance: records of indoor table list that record of outdoor table. Cause: earthquake disruption is a primary cause. Its manual sensor shut down, but API continue uninterrupted data collection. Result: complete indoor data grab while outdoor data flows continue. Secondary cause: technical limitation, Wi-Fi connectivity issues. Solution: time-aware merge with +/- 5-minute tolerance, depth unmatched indoor observation. Data exploration before merge table of indoor table and outdoor table. From the picture, we find missing value but no missing values in indoor data and outdoor data. This is our data statistic of indoor table and outdoor table. Indoor and outdoor temperature: indoor IQR is about 24.5 Celsius to 26. Outlier presence of at least one extreme low value suggests occasional cooling events. And outdoor temperature IQR is about 31.27 Celsius to 35.5 Celsius, is wider spread and is no outlier, consistent natural variabilities. Distribution of indoor and outdoor humidity: indoor IQR is approximately 9%, suggests controlled environment. Outlier possibly a temporary spike. Outdoor humidity IQR is 19%, reflects natural weather shifts. Outlier likely an arid event or measurement error, and notable asymmetry wide range from min to max. Correlation between indoor humidity and indoor temperature: a correlation coefficient of minus 0.31 indicates a moderate negative relationship, suggesting that as indoor temperature increases, humidity tends to decrease, though the relationship is not strongly linear. Correlation between outdoor humidity and temperature: a correlation coefficient of minus 0.78 indicates a strong negative relationship, meaning that as indoor temperature rises, humidity decreases more consistently, although the relationship is still not perfectly linear. Preprocessing of merge table. In preprocessing, we convert time to data to date time and sort time, then set index. In next preprocessing, we drop column that unnecessary. We merge table by keep only outdoor record that match an indoor timestamp within 5 minutes and check missing value, remove rows where there was no matching indoor data.
Analytic technique, time series analytic. Time series analytic refer to techniques used to analyze data points collected over time. First, to identify pattern, trends, seasonality, and anomaly. To forecast future value, like predict temperature or humidity for energy optimization. To understand relationships, how outdoor conditions impact indoor climate. To detect anomaly, sensor failure, HVAC malfunction, or extreme weather. This is temperature trend graph. Over the period from March 25 to April 11, 2025, outdoor temperatures consistently higher than indoor temperature by 5 to 10 Celsius. Indoor temperature shows controlled variation between 20 to 29 Celsius. There is a noticeable dip in indoor temperature around April 5th. The field data section shows gradual trends that connect the actual measurement. Humidity trend graph span from March 25 to April 11, 2025. Indoor humidity is generally more stable compared to outdoor humidity. Outdoor humidity shows significant fluctuations with extreme peak reaching over 90% around April 10 to 11. There is a notable drop in outdoor humidity to about 25% around March 28 to 29. The field data between March 30 to April 3 shows a greater increase in outdoor humidity. This graph shows average temperature by hour throughout the day. Indoor temperature remains relatively stable between 25 to 26 Celsius. Outdoor temperature shows a clear day and night pattern, rising from morning to peak around 35 Celsius in early afternoon. The temperature difference between indoor and outdoor is substantial. Next, demo with tool or libraries or coding. Our group uses Python. You can click the demo link to see the Google Colab. We will use the merge table and we made sure the timestamp column was converted into a data format and set it as the index. This allows us to handle time-based operation easily. And we also reassemble the data into 10-minute intervals because our data collection was not perfectly continuous. We took the average value in each 10-minute block to smooth the data, and then we used interpolation to fit the small gap. It helped us create a consistent and continuous time series that is easier to analyze. We also calculate the time difference between each data point using diff and check if there were any missing or irregular graphs. And then we plot the humidity trend graph, temperature trend graph. We also plot the correlation scatter plot to show the correlation between indoor and outdoor conditions. We also have the average temperature by hour. For the evaluation, our group evaluation from data quality. First, we evaluate gap in the collection. As you can see, the data records were corrected at a 10-minute interval. Second, we evaluate by data completeness. we can see that our data reached 100% data correctness. The second evaluation, our group used usefulness evaluation. From the analytic features such as temperature differences and time of day averages, reveal useful pattern for generating racing and comfort suggestions. This analysis confirmed the quality and relevance of the collected time series for further insight generation. List of possible applications. First, smart home climate monitoring, monitored and logged. Monitor and log indoor temperature and humidity. Compare with outdoor weather. Track historical condition by day and time. Basic recommendation. Suggest office based on temperature, humidity, and weather. Adaptive recommendation for personal comfort. Comfort optimization alert. Notify user when indoor air quality or temperature exceeds thresholds. For example, open window or turn on fan suggestion. Last one, weather-based decision support. Compare real-time indoor versus outdoor comfort guide. First, window vent control, air condition usage, going outside or staying in. This is list of our reference. Thank you for watching.